So solve equations. Isolate the variable on one side of the equals sign by simplification, meaning the kind of simplification we just did in section 1-2, and then performing operations to both sides. Right? The solution is whatever is on the other side of the equal sign. So we'll go from here. We'll do one. We'll just remind. This is pretty basic stuff. I don't think you guys will find this hard at all. Not the first couple. Simon. Right there. Okay. Can I go on? Okay. So this is a pretty straightforward. There's one variable. It's raised to the first power, right? That's about as simple as it gets, right? So when we say simplification, look at both sides. Look at the expressions on both sides of the equal sign. Is there any combining of like terms or distributive property or anything we can do? No. So we can go ahead with, hey, we need to do operations to both sides. Now, it does not matter too much what that first step is. You could subtract 8z from both sides, subtract 12 from both sides, subtract 5z, or add 21 as a first step, and still be on track to get a right answer. But what do you think the recommended first step is? Subtract 5z, right? Subtract 5z. Usually you deal with the variable terms first, and you try to move the variable terms to the side which has the greatest coefficient of the variable term. So which is the bigger coefficient, 8z or 5z? 8z. So move the 5z, meaning that's a positive 5z on the right, subtract 5z from both sides. 3z plus 12 equals negative 21. Okay, at that point now, pretty much there is only one step you would want to take next. What would that be? Subtract 12, right? You don't want to divide by 3 first. If there's two terms and one term doesn't have the variable in it, move that term first. Subtract 12, subtract 12. 3z equals negative 33. Now, last step, divide by 3. So z equals negative 11. And how could you check to see if that's true? You could plug it into the original equation here and make sure that what it simplifies to on both sides is equal.